So with difference of squares, this is another type of factoring. The first thing you want to do is check to see if there's a greatest common factor. If there is, you want to do that first. Then, in order to use difference of squares, you have to see, is it a binomial, which means it has two terms? Is it a subtraction problem? And are both terms perfect squares? So perfect squares are things like 1, 4, 9, 16, 25, things like that, where you can take the square root of a number and get a whole number. You also have variables that are perfect squares, and they're every even variable exponent. So for example, x times x is x squared. So x squared is a perfect square. X squared times x squared is x to the 4. So x to the 4 would be a perfect square. X to the 10 times x to the 10 would be x to the 20. So x to the 20 is a perfect square. So basically, even variable exponents. All right, they're all perfect squares, and you would just divide them by 2 to figure out what their perfect square was, because when you are multiplying with exponents, you really add them together. So if you just divide by 2, then you'll get the right exponent. So on this first one, there's no GCF, but they are perfect squares. It is a binomial. It is a subtraction problem. So we would break it apart, and you'd have two parentheses. To get x squared, you'd have an x times an x. To get 9, 3 times 3. But the only way to get a negative 9 would be for one of them to be a positive and one of them to be a negative. So those are the factors of x squared minus 9. The second example works the same way. So we have our requirements met, two terms, subtraction problem, perfect squares. So we would have x and x, 7 and 7, and then a plus and a minus. Because the square root of 49 is 7, square root of x squared is x. The third example, you don't have a GCF, but you do have perfect squares, a subtraction problem, and a binomial. So we'd have two parentheses. To get 4, you'd have 2 times 2. To get x squared, x times x. And to get 25, it'd be a 5 and a 5. But because of the negative, one has to be plus, one has to be minus. For example 4, you would divide out of 5 because you have a GCF. So we keep the 5, and we're left with x squared minus 4. And then in the second piece, we do have difference of squares. So we keep the 5, we have our two parentheses, we have an x with a plus 2 and an x with a minus 2. In the fifth example, you have two terms, perfect squares because 25, the square root of that is 5, x to the 16 because it's an even exponent. So we would separate it, and we'd have x to the 8, and a plus 5, and a minus 5. And that's because, remember, if you multiply exponents, you really add, and 8 plus 8 is 16. So be careful about using 4, because it's an exponent. You don't really take the square root. You have to think a little bit differently because of the properties of exponents. For the last example, we have our requirements met, two terms, subtraction, even exponent, perfect square. So we would have x to the 4, because 4 plus 4 is 8, and then a plus 10 and a minus 10, because the square root of 100 is 10. And that's it. So sometimes you will have situations where you have like, if I had x to the 9 minus 16. If that was an example or a problem, then this would be considered prime. And that's because it would not meet the requirements of difference of squares, because the 9 is not an even exponent. So you couldn't do that using difference of squares.